Hello again, sixth graders. So over the past couple days, we have taken a look at the area of parallelograms followed by the area of triangles. And today we're going to focus our energies on the area of trapezoids. Trapezoids are funky shapes, and it does kind of have a funkier formula that's a little bit more difficult to remember. But the cool thing is that it's still somewhat similar to the parallelogram and triangle. So hopefully we can figure out a way to help that stick in our brains, because eventually we will need to memorize these formulas. And that's also part of why I want you to do the trifecta when we're doing this, writing the formula for the first thing, substituting in, and then solving with your units, because writing the formula over and over again will help you to memorize it. So let's talk about what defines a trapezoid. So a trapezoid, is a quadrilateral. Quad meaning four, so it has four sides, with only one set of parallel sides. So this is different than a parallelogram, because parallelograms have two sets of opposite parallel sides. A trapezoid only has one set. And these parallel sides will not be equal, because actually it turns out if they were equal, if I stretched that out so that they were equal in length, this would actually, the sides would drop down and it would make a rectangle, and a rectangle is defined as a parallelogram. So in order to also be a trapezoid, the parallel sides must not be equal. We call those unequal parallel sides the bases, and we're going to label them B1 and B2. So again, these are subscripts. When they're written really tiny and down below, we call those a subscript. And we're going to use those just to differentiate the top from the bottom, or if it was like kind of rotated, we're just differentiating the two unequal parallel sides. So I think in general, I usually, oh gosh, I don't even remember. I think I'll go ahead and put B1 on the top and B2 on the bottom, but you can totally switch those up. There is no law that says, you know, the top has to be this or that. So just kind of go with whatever you do first. So let's go ahead and label the parts of this trapezoid. So at the top, I'll go ahead and label that B1, base 1, and the bottom I will label base 2. These arrows indicate that they are parallel, and our height, if you recall, our height must be, for all area formulas, heights must be perpendicular to the bases. So this height will actually need to be perpendicular to both of the bases. So we're going to be looking for lines that create right angles with the bases. And the area of a trapezoid, and this is going to be really important that you memorize this, is 1/2 times the height times not just the single base, but times the sum of the bases. So B sub 1 plus B sub 2. So this is actually kind of similar to the triangle formula, because if you remember, the triangle formula was 1/2 times base times height. Now we don't have just one base here, we have two bases. So instead of the triangle where it's just 1/2 times a single base times a height, this is 1/2 times the sum of the bases times the height. So that might help you to remember this formula, and this formula will never change. This is always the formula you will use when you're calculating the area of a trapezoid. Do you use this for the area of a rectangle? No. Do you use this for the area of a triangle? No. Do you use it for the area of a trapezoid? Yes. So please remember, again, the base and the height have to be perpendicular, which means, it's a fancy word, meaning that they form a right angle. All right, so let's jump right in. Let's calculate the areas of these trapezoids. So again, these appear to be parallel. I'm going to draw just two arrows to denote that they're parallel. But notice, are they equal? They are not. So this is what constitutes a trapezoid. So I'm going to go ahead and step 1, I'm going to write the formula. So the area of a trapezoid is 1/2 times the height times the sum of the bases, base 1 plus base 2. And step 2, I'm going to substitute in. So this area of the trapezoid is going to be 1/2 times, take a look at how 10 is perpendicular to both of the bases, that's my height, times 10 centimeters, times the sum of 12 centimeters plus 9 centimeters. Sorry, I'm kind of running out of room here. And step 3 is to solve with units. So we have the area of the trapezoid is 1/2 times, well, shoot, I should have, that's okay. We'll keep going with it. Times 10 centimeters times, that is 21 centimeters. My next step, half of 10 is 5 centimeters times 21 centimeters. And 5 times 21 is 105 centimeters times centimeters is centimeters to the second power square centimeters. It is so important that you include the unit, and it must be to the second power. If it is not, you will be losing some points because you did not use the correct units. All right, let's do another example. So the area of this trapezoid will be 1/2 times the height times the sum of your bases, b1 plus b2. Again, doesn't matter which one you pick to be the top or the bottom, doesn't matter because you can flip-flop those thanks to the commutative property. So the area is going to be 1/2 times 2 feet because the 2 feet is perpendicular to both of those bases that are at the top and bottom, and times the sum of this. So it's going to be times 1.5 feet plus 3 feet. All right, and let's start solving. So half of 2 is 1. So that's 1 foot times the sum of 3 and 1.5, which is 4.5 feet, and 1 times 4.5 is 4.5. A foot times a foot is now a square foot. So the area of that trapezoid is 4.5 square feet. Let's do one more example, and then we're going to take a look at the missing dimension like we've been doing with every shape thus far. Let me make sure I'm sliding this up far enough, okay? So let's take a look at the area of this desk that is a trapezoid shape. So we'll go ahead and have B1 be 36, base 2 be 18, and the height has to be perpendicular to it, so the height is 24. So the area of a trapezoid, and I do want you doing the trifecta, which is writing the formula so that this gets ingrained in your brain, followed by substituting in. So this is going to be 1/2 times 24 inches times 36 inches plus 18 inches. Okay, and now we can start solving. I'm going to go ahead and do this. Half of 24 is 12. And the sum of 36 and 18, let's see, we've got 454 inches, and now I need to multiply 12 times 54. I'm going to come up here, do some scratch work. 0, carry the 1, 5, 6. So we got 648 equals 648 inches times inches give you square inches. Okay, so that is simply calculating the area of trapezoids. Again, this is a somewhat complicated formula that you will need to memorize. But let's go ahead and take a look at finding the missing dimension. So again, we're going to use our algebra skills here. I'm going to give you the area and give you either one of the height or one of the bases, and we can figure out the missing dimension by using our algebra skills. So again, we're going to use the formula, we're going to substitute and solve for the unknown. So here we go. Let's find the height of a trapezoid with an area of 24 square inches and a base of 6 and 2. So the first thing I want to do is write the formula. The area of a trapezoid is 1/2 times height times base 1 plus base 2. Okay, and substitute in. So we know the area is 24 square inches is equal to 1/2 times unknown height times the sum of 6 inches plus 2 inches. All right, let's start solving now. So we've got 24 square inches is equal to 1/2 times the height times 8 inches. We have a couple of options. I can simplify this side, which I'll do because 1/2 of 8 isn't too bad. Now I'm using my commutative property. I'm flip-flopping those, so I'm doing 1/2 times 8, which is 4 inches times the height is going to be equal to 24 square inches. I divide by 4 inches, and I get 6 inches to the first power is equal to my height. Again, Miss James will teach you, and potentially I might toward the end of this year, that inches squared divided by inches to the first power does leave you with inches to the first power. All right, and let's do one more together, and then I want you to try those two problems on the bottom on your own and check the answer key on the website. So let's find one of the bases. If our area is now 30 square yards and the height is 10 and the other base is 4. So let's start by writing our formula as always. Okay, we have 30 square yards is equal to half times 10 yards times b sub 1 plus 4 yards. Okay, that's what we're solving for. So let's go ahead and simplify a little bit. So I know that 30 square yards is going to be equal to 5 yards, because half of 10 is 5, times b sub 1 plus 4 yards. Now, if you remember with SADMEP, our algebra skills, parentheses is last. So I need to get rid of everything leading up to parentheses. So that means I need to get rid of my 5 yards first. So I'm going to get rid of that by dividing by 5 yards. And I get 6 yards are equal to b sub 1 plus 4 yards. And because these 5 yards cancel out, and now I just subtract 4 yards, because how do you get rid of adding 4 yards? You subtract them. And we get 2 yards is equal to base 1, and we can plug back into the original and make sure we get the correct answer. Let's test it out. Is it true that half times 10, which is 5, times the sum of 4 and 2, well, 4 plus 2 is 6. Is it true that 5 times 6 gives you your original 30? It does, so it seems like we have gotten this right. I want you to take a look at the, try it yourself, do the bottom 2 problems on your own, and check the answer key on the website.